Download this code from codegive.com, link in the description below. Building a clean architecture. .NET Core 9 Web API, a detailed tutorial. This tutorial will guide you through building a .NET Core 9 Web API using clean architecture principles. Clean architecture promotes maintainability, testability, and scalability by separating concerns into distinct layers. We'll cover project setup, layer definitions, data access, dependency injection, and example endpoints. Why clean architecture? Testability. Each layer is independent and can be tested in isolation. Maintainability. Changes in one layer have minimal impact on other layers. Flexibility. Easily swap out dependencies like databases or frameworks without rewriting core business logic. Scalability. Clear separation of concerns facilitates scaling different aspects of the application independently. Prerequisites. .NET 9 SDK, https://.net.microsoft.com/n-a/download. A code editor, Visual Studio, VS Code with C extension, Writer. Basic understanding of C, ASP.NET Core, and dependency injection. Project setup. 1. Create a solution. Open your terminal or command prompt and create a new solution directory. 2. Create projects. Create the following projects within the solution. Core, class library contains entities and interfaces defining business rules. Application, class library contains application logic, use cases/commands/queries, and DTOs. Infrastructure, class library contains implementations for data access, external services, and persistence, Fcore. Web API, ASP.NET Core Web API. The entry point of the application, handles requests, serialization, and exposes endpoints. 3. Add projects to the solution. 4. Project dependencies. Establish the necessary dependencies between projects. Think of it this way: outer layers depend on inner layers, but inner layers have no dependency on outer layers. Application depends on core. Infrastructure depends on core and application. Web API depends on application. Use the following .NET add reference commands. Project structure. Your solution structure should look something like this. Detailed layer implementation. 1. Core layer, entities and interfaces. This layer holds the business entities and interfaces that define the core business logic. It's the most stable layer and should be independent of any external frameworks or technologies. Entities represents the domain objects, example product, order, customer. Interfaces define contracts for repositories, services, and other components that will be implemented in outer layers. Example, core/entities/product.cs. Example, core/interfaces/iProductRepository.cs. 2. Application layer, use cases/commands/queries, DTOs and contracts. This layer contains the application logic, including use cases, commands, queries, and data transfer objects, DTOs. It orchestrates the core business logic from the core layer and prepares data for presentation or persistence. DTOs, data transfer objects, represent data that is transferred between layers, often used to expose data to the API. Contracts define interfaces or abstract classes that define communication between the application layer and the infrastructure layer. These are often interfaces for application services. Use cases, features represent specific actions or operations that the application can perform, example create product, get product details. They are typically implemented as classes that encapsulate the required logic. This can be further structured using the command query responsibility segregation, CQRS, pattern. Example, application/dto/product dto.cs. Example, application/contracts/iProductService.cs. Example, CQRS applications/features/products/queries/getProductById/getProductById query.cs. Example, CQRS applications/features/products/queries/getProductById/getProductById query handler.cs. 3. Infrastructure layer, data access, external services, persistence. This layer provides concrete implementations for the interfaces defined in the core and application layers. It interacts with external systems like databases, APIs, and file systems. Data handles data access and persistence. Repositories implements the repository pattern, providing an abstraction layer for data access. They interact with the database context. Services implements application services based on contracts in the application layer. Example, infrastructure/data/application db context.cs, using entity framework core. Example, infrastructure/repositories/product repository.cs. Example, infrastructure/services/product service.cs. 4. Web API layer, controllers and API endpoints. This layer is the entry point of the application. It receives HTTP requests, translates them into application commands/queries, and returns responses. It depends only on the application layer. Controllers handles HTTP requests and calls application services. Serialization/deserialization handles converting data between JSON and .NET objects. Example, Web API/controllers/products controller.cs. Dependency injection and configuration. 1. Configure services in Web API/program.cs. Register your services, repositories, application services, with the ASP.NET Core Dependency Injection Container. This is crucial for decoupling and testability. 2. Create an auto-mapper profile in application/application profile.cs*. Configure auto-mapper to map between entities and DTOs. Example, adding fcore migration. 1. Install fcore tools*. 2. Add a migration*. Navigate to the infrastructure directory and run. 3. Apply the migration*. Run the migration to create the database schema. Testing. Write unit tests for each layer to ensure that your application behaves as expected. Use mocking frameworks like mock to isolate components and test them independently. Example, unit testing the product service. Key considerations*. Solid principles*. Adhere to the solid principles, single responsibility, open/closed, Liskov substitution, interface segregation, dependency inversion, to create a well-designed and maintainable application. Error handling*. Implement robust error handling and logging mechanisms throughout the application. Validation*. Validate user input at the API layer and business logic at the application layer. Asynchronous programming*. Use async and await for I/O bound operations to improve performance and responsiveness. CQRS and mediator*. For more complex applications, consider using CQRS and the mediator pattern to further separate command and query responsibilities. Install Mediator via .NET Add Package Mediator version 12.2.0 and .NET Add Package Mediator.extensions.microsoft.dependency injection version 12.1.2. Further improvements. *authentication/authorization *implement authentication and authorization to secure your API. *caching *implement caching to improve performance by reducing database calls. *health checks *add health checks to monitor the status of your application and its dependencies. *API versioning *implement API versioning to manage changes to your API over time. *Swagger/Open API *Use Swagger/Open API to document your API and generate client code. *Use of Fluent validation instead of just using data annotations for validation, integrate Fluent validation in the application layer for more powerful and testable validation. This comprehensive tutorial provides a foundation for building a clean architecture .NET Core 9 Web API. Remember to adapt this example to your specific requirements and continually refine your design as your application evolves. The key is to maintain clear separation of concerns and adhere to the principles of clean architecture to create a maintainable, testable, and scalable application.